All right, so we need to start off with a quick couple pieces of just vocab really quick. So what is the little number or variable that's up top? That's the exponent, right? So exponent. Okay, that's the thing that we are going to be focusing on this entire unit, okay, the exponent. Does anybody know, and notice, the exponent does not necessarily have to be a number, it could also be a variable, okay? And we'll see that, when we do exponential functions, our exponent will be a variable, and that's fine. Does anybody know what the big thing is that the exponent sits on? Michael? It is the base, right? Because sometimes it could be a variable, it could be a number. It's called the base. Okay. What does 5 to the third really mean? 5 times 5 times 5, right? So 5 to the third really means 5 times 5 times 5. So we want to come up with rules based on different things that we are asked to do with exponents. We want to come up with rules. But how much fun would it be if I just told you the rule? That would be fun at all, wouldn't it? Then that would just, yeah, I'm sure you would like it. Okay, but it would be meaningless to you if I just told you the rule. So we're going to go back to the basics. We're going to go back to this idea of what the actual definition of exponents in order to come up with the rule yourselves. Okay, so the first thing that we're going to talk about is multiplying different terms that have exponents on them. Okay, and we are going to go back to expanded form in order to figure out our rule. So looking at 8 to the fourth times 8 to the second. So again, what does 8 to the fourth really mean? There you go, 8 times 8 times 8 times 8. So I'm just going to write it out in expanded form. And then I want to multiply that by 8 to the second. So what is 8 to the second? 8 times 8. Okay. So now I want to kind of bring this back down into a single term with an exponent. I don't want you to start typing into your calculator 8 times 8 times 8 times 8, because I know you could do that. Okay? So if I take 8 to the fourth and I expand it back out into 8 times 8 times 8 times 8, if I wanted to simplify this whole thing back into one term, talk about really quick with your groups what it would be and why. Don't forget the y part. Okay, what'd you guys come up with? 8 to the 6th. Can somebody tell me why? You guys are going too far for me. Yeah, Jadlin?
Because there's 6 8s.
Okay, because there are 6 8s, right? So it's kind of the reverse of what we just did. We took 8 to the fourth and expanded it out to 4 8s multiplied together. Now we have 6 8s multiplied together, so that would logically turn into 8 to the 6th, right? Okay, so what about 8 to the third? 8 times 8 times 8. Multiply by another 3 8s with another 8 to the third, and I come up with a total of 6 8s, so that's 8 to the 6th. Okay, so 5 seconds with your partners. Fill in the statement that's underneath there. To multiply numbers with the same base. What rule did you come up with? When we're multiplying, what do we do with exponents? Yes, Zach?
You add the exponents?
Yep, you add the exponents together. Okay? So it's as simple as that. Because logically you can see I have 4 8s here, 2 8s there. Add them all together, I get 6 8s, so 8 to the 6th. So I'm just adding their exponents. All right, you have 4. Try these there. It says example 2. I want you to do those 4 together with your partners. Go ahead. Okay, so on A, I have 4 11s and 5 more 11s, so that makes 9 11s, so 11 to the 9th. Okay, on B, I have 5 2s and 2 more, that makes 7 2s, so 2 to the 7th. On C, what is X?
1.
X to the first, right? It's just a single X. So if you really want to, if you really want to, you can put a little placeholder of 1 as the exponent. So a single X and 2 more makes 3 X's, and 4 more makes 7 X's. So I have X to the 7th. All right, D, I saw a lot of this on people's papers. Is that right or wrong? That is wrong. What is m in? What operation? What is m in? Multiplication, right? When two things sit next to each other, that's multiplication. Is our rule to multiply exponents? No, so I would not want m in as my exponent. So I'm going to get rid of that. In all of these, my base has never changed. So the base of 5 is correct. But what should my exponent be? M plus n, right? So it should be 5 to the m plus n power. It's not necessarily pretty, okay, but that's it. 5 to the m plus n. Okay, can I get a comfort level how you feel right now? 0, 1, 2, or 3? 5, wow. Okay, all right, so now let's look at some problems where we have more than one base. Okay, and before we do this, I need you to tell me what the difference between these two 5s are.
They have different exponents.
You didn't even write it up yet.
I haven't even written it yet.
What's wrong?
Oh, I thought you were talking about
No,
D.
stop.
It was like,
Okay, so tell me what the difference between these two 5s are.
One half of it.
They have a very different function here. Just going to let it soak in for a second. I see all your hands, it's fine. Just let people think for a second. Okay, now everybody answer this question for me. What is this 5? It's a base, right? How do you know it's a base?
because there's an exponent.
Because it has an exponent on it, right? So this 5 is a base. What is this 5?
No, it's not.
Okay,
Variable.
so this 5 does not have an exponent on it, right? The exponent is on x. So it's not a base. What is it?
A variable. No,
It's not a variable.
What's it called? It's just a number.
It's not just a number. It has an actual name
I forgot what it's called.
for the number that sits out in front of a variable.
Multiplier?
We have called it that in the past, but that's not the name of it. Starts with a C.
Coefficient.
Yeah, it's a coefficient. Okay.
I was close.
All right, so we have the difference between a base and a coefficient. The main difference is if it has an exponent or not. Okay, and we have to know the difference because... Oh, go away. There we go. Because when I approach a problem, I treat coefficients very, very differently than I treat bases. You'll hear me say about 5 million times this unit, coefficients do what you see. So whatever operation you see happening, that's what you do to the coefficients because there is nothing special about them. They do not have exponents on them. I do not treat them any differently than I ever have in the past. So when there's more than one base, we want to multiply the coefficient. Okay, so multiply the coefficients because in this specific case we are multiplying. And then combine those powers with like bases. Okay. All right, so let's look at example 3a. So what would my coefficients be here on 3a? 2 would be a coefficient because it does not have an exponent. What else? 30. So those are my coefficients. Those are the numbers sitting out front that do not have exponents. So what does it mean when two sets of parentheses are sitting next to each other? Multiplying. So I do what I see. I see multiplication, so I do what I see. 2 times 30 gives me 60. Nothing special about that. Now I see bases. So now I apply my new exponent rules. So I'm looking here and I see 5 n's. That's what n to the 5th means. And another n back here. So what do I have? N to the 6th. Because I add exponents. Okay? So you see that you do something very different to coefficients than you do to the bases. Okay? So coefficients do what you see. B gets a little more challenging because now I have 3 sets of parentheses. What I like to do with 3 sets of parentheses is do a piece, mark it out. Do a piece, mark it out. Do a piece, mark it out. So that I make sure I don't miss anything and I don't double count anything. So on B, what are my coefficients here? 5,
Negative 2.
-2, and 3. So do what you see. 5 times -2 is -10, times 3 is -30. And then I mark out my coefficients because I'm done with those. I move on to x's. So in my first term, I have a single x. Second term, how many x's do I have? None. What about the third term? How many x's do I have? 8. So now I have a total of 9 x's. So x to the 9th. And I'm done with x's. Now move on to y's. I have a single y up front. 4 more y's in the middle. That makes 5. So I have y to the 5th because there aren't any at the end. Mark out my y's. And then z's. I have 2 z's in the middle and 3 z's at the end. So that's z to the 5th. Okay, and I put a little slash through my z so you can tell the difference between that and a 2. Just FYI. So I have -30, x to the 9th, y to the 5th, z to the 5th. And I've combined all of my like bases. I've multiplied all of my coefficients, so I'm done. Okay? All right, how we doing on? We still got plenty of time. So go ahead and do the 4 try these down at the bottom of that page. Okay, so do the 4 try these down at the bottom of the page with your partners. Go ahead. Okay, so A is actually a little tricky because 6 out front kind of looks like a coefficient because it does not have a base on it. But then you see another 6 that does have a base on it. That does have an exponent on it. So I do want to treat them as bases, right? I have a single 6 and 2 more 6s, so that's 6 to the third power. 6 to the third power. There we go. I'll just do C since I already have it here. Coefficients, do what you see. So I have -2 times 3, that's -6. And then add your exponents, right? Apply your exponent rules to your bases. So I have C to the 2nd and C to the 3rd. That makes a total of 5C, so C to the 5th. Any questions on those two? Okay, B, another easy one. I have 3 J's and 4 more J's. That makes a total of 7 J's, so J to the 7th. And then D gets a little bit more difficult, right? Coefficients of 3, -5, and what's the coefficient of the last term? -1, right? Because it's -1 times all that stuff. So I do what I see with the coefficients. 3 times -5 is -15. Times -1 would be a +15. So there's my coefficient, done with the coefficients. Now x's, so I have a single x and 2 more, that makes 3 and none in the end. So 3 x's, so x to the 3rd. Done and done. Y's, I have 2 y's and 1 more make 3 y's and 3 more make 6 y's. So y to the 6th. Do not try to apply the negative to the y, right? Don't think that that's like a -3 exponent. If it was going to be a -3 exponent, it would literally be y to the -3rd. Okay, so you got to be careful there. And then lastly, z's, I don't have any in the first term, don't have any in the second term, and I just have 1 at the end, so 1 just stays there. So 15 x to the 3rd, y to the 6th, z. Okay, can I get a comfort level on how you feel with multiplying with exponents? 0, 1, 2, or 3? Good. Feeling good. Okay. So now let's look at our second exponent property when we are looking at dividing with exponents. So that's around to the back or the second page, however you have it. Okay, so let's look at dividing exponents. And again, we will learn a rule, but we need to go into expanded form to learn that rule because I'm not just going to tell it to you. So expanded form here, 5 to the 6th power, just like we had on the front, is 1, 2, 3, 4, 5, 6 5s. Okay, 5 to the 6th power is 6 5s. And then I have 5 squared on bottom. That's 5 times 5. And go ahead. How do we simplify fractions? Just kind of cancel stuff top and bottom, right? That they have in common. So I have a 5 on top and bottom I can cancel. And another 5 on top and bottom that I can cancel. I've canceled as much as I can. What am I left with? 4 5. So that's 5 to the 4th. Where? Because that matters.
On top.
On top, right? So I have 5 to the 4th on top. What am I left with on bottom?
Wait.
5.
No, it's just.
If you divide everything out of a number, what are you left with?
Nothing.
1, right? Like if I divided 9 out of 9, I would have 1. So I have a 1 left over.
You have to make it a fraction at the end.
No. So a 1 on bottom doesn't really mean anything in math, right? So I can just simply write my answer as 5 to the 4th. I just wanted to kind of show that because it will be important a little bit later. We'll see where. Okay, then we have 3 to the 7th. So that's 1, 2, 3, 4, 5, 6, 7 threes. 3 to the 3rd on bottom is 3 threes. I cancel as many as I can, so that's going to be 3 of them. And I'm left with 3 to the 4th where? On top. So 3 to the 4th on top over 1. And I can simply reduce that to just 3 to the 4th. Okay? All right, so I'll give you another 5 seconds. Go ahead and try to fill in your rule. To divide numbers with the same base, fill in your rule. Okay, what rule did we come up with? Subtract, right? So we are subtracting the exponents. Okay. Just like you can see here, we have 5 to the 6th divided by 5 to the 2nd. So 6 minus 2 leaves me with 5 to the 4th up on top. 3 to the 7th divided by 3 to the 3rd. 7 divided by 3 is 3 to the 4th. Remember that our bases are not changing, right? I don't do anything with the bases. It is only coefficients that we change. Okay, bases do not change. So let's look at a couple examples here together. I just want to look at just a couple. So let's look at A. No, I'm not even going to look at A. I guess, might as well, whatever. So A to the 16th divided by A to the 4th. So I subtract my exponents. 16 minus 4 leaves me with A to the 12th. Where does that A to the 12th go? On top. So I can just leave it as A to the 12th. You can put over 1 if you want to, but you don't necessarily have to. Okay? Then I move to B. So I have B to the 5th on top, B to the 10th on bottom. I do not want to mess with negatives right now. We'll learn how to later on, but for now I don't want to mess with it. So I'm still going to do bigger minus smaller. Think about it. If I wrote this out in expanded form, I would have 5 B's on top, 10 B's on bottom. I would cancel out as many as I can. So 10 minus 5 would be 5 B to the 5th. But where would that B to the 5th be left? On the bottom, right? So on the bottom of the fraction, I'm left with B to the 5th. What would I be left with on top? A 1. Now, can I just get rid of my 1 and leave this as B to the 5th? No, 1/2 is definitely not the same as 2, right? We use the same logic here. 1 over B to the 5th is not the same as B to the 5th. So, name of the game here, or moral to the story, I guess, is more appropriate probably. My bigger exponent is on bottom. So that's where my simplified exponent needs to go, okay? All right, let's look at C and F together, okay? C and F together. So on C, what is 3 divided by 18? Those are coefficients, right? 3 divided by 18 are, 3 and 18 are coefficients, so I do what I see. So what's 3 divided by 18?
No, if it was the other way around, it would be.
Right, if it was 18 divided by 3, it would be 6. Okay, I'm going to... No, it's not a negative because I would have to have a negative in my problem to do that. So that being said, I'm not going to get a whole number, so I simply need to reduce my fraction. So what could I divide out of 3 and 18 both? 3. So divide a 3 out of 3, I'm left with 1. Divide a 3 out of 18, I'm left with 6. So really I do kind of end up with 6, but it's a 6 on bottom, right? So that's why I have to be careful there. All right, what about S's? I have S to the 6th on top, S to the 2nd on bottom. So my bigger exponent is on top. So I subtract and my answer goes where? On top. So 6 minus 2 is 4, so I have S to the 4th up on top. What about my R's?
They cancel each other.
They're the same, so they cancel out and they are gone. So R's are gone. Make my fraction bar a little smaller there. And there's my final answer, S to the 4th over 6.
Did you put 1 S to the 4th?
Sure. Okay, and lastly, let's look at F. What is 6 divided by negative 2? That one really is negative 3, so you're safe to go ahead and put your negative 3 on top. A's, where's my bigger A? on bottom. So 7 minus 1 is 6. So a to the 6th goes down on bottom because that's where my bigger exponent was. And then b's, my bigger b is on top. So 2 minus 1 leaves me with a single b on top. So I have negative 3b over a to the 6th. Okay. What?
No.
Can I do D? Sure. Okay, let's look at D. Ooh, let's look at D. You guys do D. You guys try D. I'll give you a minute. Try D. Think about your exponent rules. Think about what you're supposed to do. Think about what the exponent is on bottom. Okay, so let's logically work through this. What is the exponent on bottom? 1. It's a to the first. What is my exponent rules when dividing? You subtract. So my base stays the same, and I would subtract, so I have x plus 1 on top, and then I subtract off the exponent on bottom.
No, I just put AX.
So what's my answer? A to the x power. I kind of took an expanded way of doing it. You didn't necessarily have to do that middle step, but I was just showing that so that people didn't get confused. Okay? All right, so you now have 4, I think. Yeah, 4. Try these problems down at the bottom. Go ahead and try those 4 with your partners. Go ahead. Okay, so on A, where is my bigger A? On the bottom. So when I subtract 8 minus 3, I'm left with A to the 5th on bottom. And yes, you have to have 1 above. Okay? All right, I'll just go ahead and do C since it's here. Negative 27 divided by 3 is negative 9, and that's on top. My A's, I just have a single A on top and bottom, so those cancel. I have more B's on top, so 3 minus 1 leaves me with B squared on top. And I have more C's on bottom, so I need to make a bottom. So 6 minus 5 is just a single C down on bottom. So negative 9B squared over C. And then B and D. B, 2 divided by 10 is not 5, so don't say it's 5. Okay, my bigger number's on bottom, so I have to reduce my fraction. That becomes 1 over 5. So my 5 is on bottom. I have more J's on top, so 3 minus 1 leaves me with J squared on top. And again, if you put a 1 on top, that's fine. So J squared over 5. D, you have options. You could reduce the fraction by dividing and then multiply, or you could multiply first and then reduce your fraction. I will multiply and then reduce my fraction. How about that? How do you multiply fractions?
Add. Well, not fraction.
Wait, multiplying. Oh
I don't know.
Same.
Common denominator.
That's adding.
god.
Cross multiply.
Cross multiplies when you have an equal sign in the middle.
Jesus.
Okay, well, I need to make the second one a fraction by putting it over 1. How do I multiply fractions?
Oh, top and bottom.
Just top and bottom, right? Just straight across.
Yep.
Okay, all right. We made it, finally. So I have 6 times 2. Those are coefficients, so I just do what I see. That's 12. I have a single x in the second fraction, so a single x. I have 3 y's up front and another y here, so that makes y to the 4th. Then on bottom, I'm just left with that 18x. Now go ahead and reduce your fraction. So what can I divide out of both 12 and 18?
No, never mind.
Not 4.
Never mind.
6. So if I divide a 6 out of 12, I'm left with 2. If I divide a 6 out of 18, I'm left with 3. So I have 2 on top, 3 on bottom. X's cancel cleanly because there's only 1 on top and bottom. And y to the 4th is up on top, so that stays there. So I have 2y to the 4th over 3.